자, 그럼 이제 본격적으로 주제 발표를 시작하도록 하겠습니다. 첫 번째 세션은 미래 전망이라는 주제로 국내외 세 분의 연사의 발표가 준비가 되어 있는데요. 첫 번째 발표는 싱귤래리티 대학교 창립 멤버이신 캐서린 미루눅 연사님께서 준비를 해주셨습니다. 2022 ICT 혁신이라는 주제로 발표 지금부터 함께 하시겠습니다.
Hello, I'm Catherine Mirunik. And I'm honored to speak to you today about the intersection of exponential technologies and innovation. I've had the privilege to work with diverse teams wanting to be more innovative, whether in technology, business, or sustainable development goals. They have been in new startups or older, large established corporations or NGOs across a wide variety of sectors. They might be internal intrapreneurs or entrepreneurs. These are hardworking and thoughtful teams working on meaningful and complex problems. It is my goal that far more people help innovate, whether in a company or in a country. I have had the opportunity to work with world-renowned experts at the intersection of exponential technologies and their applications. Here's a book for which I was a research analyst, testing every point on charts like this one. Working in technology and being located in Silicon Valley, I am able to meet both the people who create the start of these charts and the people who add the latest technologies to add future points. Now, exponential is often used to mean grows quickly, but it has a specific mathematical meaning. The growth is proportional to the current size. There are slower exponentials like interest rates and GDP, where doublings happen in decades. And there are the very fast exponentials that we see throughout ICT, with the most famous being Moore's law. I have observed how innovators from multiple industries and working on multiple applications understand and work with these exponential technologies. We all can learn from older and recent examples of innovation and change to help us with the complex challenges we face next year and this decade. To start off, let me ask you, how many computers do you see in this picture? Yes, there are 4 computers sitting at their desks, because back then, that was a job to do computing. You had to decide very carefully what you wanted to compute, because it was expensive. If you wanted more computing, you had to hire additional people. Before 1940, computation machinery was improving, but it improved slowly. Then we had the first digital computers, available only to governments or large universities. But as the number of computers grew, the number of users and uses grew. Computing grew to where there was excess computing available, non-scheduled computing. Now, in the 1930s, was it possible to imagine what we could do if computing was not a scarce resource? Or think in the 1960s, could we imagine what could happen if every house had a computer? It was possible to forecast the technology itself improving, becoming faster, cheaper, and smaller. But could we forecast who would be using it and how they would be using it? The first undergraduates created games late at night in the 1960s, and these helped lead to the personal computer. Now, this change may seem obvious in retrospect, but at the time, it was not obvious. Now, there are multiple types, 30, 40, even 50-year-old exponential technologies that are getting useful and exciting in part because they're infrastructure. They're ordinary, and yet they're still exponential. Now, this is a key point, to look at who is able to explore the capabilities of a technology and who can drive new uses for it. Of course, this is quite visible in ICT. Compare the growth of smart networks to the growth of stupid networks. Systems in which all the components are predefined can be powerful when they're launched. But what happens if users want to change? A fixed system starts to feel outdated. In contrast, stupid networks mean that the intelligence is at the edge with the end user. Decades ago, I, like many others, read about submarines for exploration. But at the time, there was just one or a few. I could only dream of this for myself. Today, as you see here, teenagers can build underwater robots for exploration, similar to drones. Not just a few people, but millions of people can decide what to do with this capability. Take photographs? Certainly. Take samples to test for pollution? That is also possible. Or take satellites. Satellites used to be the domain of large governments and corporations, and while they were getting somewhat smaller and less expensive, these changes were often incremental. The team at Planet looked at the problem from another angle and said, what if we could take a cell phone and put a cell phone in space? When today we see nonprofits using rapid satellite pictures to look for deforestation or to look for methane leaks or illegal fishing, they are often using Planet satellites. Now, graduate students and undergraduates can plan projects that 30 years ago only spy agencies could do, but didn't do. In other words, it isn't just about a technology, but who is using it. This data, Planet's data, is usable now. The key question for 2022 is, are all stakeholders at the table in the conversation for using this data? If, for example, governments, NGOs, or individual farmers can see how croplands are doing with satellite photography, what barriers to this use exist? If leaders in ICT wish to help with Sustainable Development Goals, connecting people with capabilities must be a priority. This is because barriers to participation are lowering. For example, we dreamed of translation when we saw it in Star Trek, but even 40 years later, when she met the president, translation software was disappointingly incomplete. Now, though, we can translate languages with our devices, the ones in our hand. It isn't perfect, but it will get better. And not just a few languages. Microsoft offers over 60 languages in its Office products. PowerPoint has real-time translation. We meet many of these technologies in fiction, years or decades before they start to be real. At first, what we think they can do is defined by the imagination of a few people. We start off envisioning these technologies as demonstrations and special effects. They're still impossible in realistic practice. When a vision first becomes not impossible, the first capabilities will disappoint us. Early versions will seem like a toy for children to play with. Here, they're playing with in a competition for football-playing robots. But those children go to college, where they can find new team projects to work on. Here are robots from DARPA's Robotics Challenge in 2013. This is not a game. We want robots to help us do rescue work in dangerous locations. Notice here, the robots have power cords and they have protective tethers, because if they fall, they might be damaged and they might not be able to get up again. In 2013, no single robot could do all of the tasks. Watching this, you might think it would take another decade or more for these robots to succeed. However, each individual task was done by at least one robot. When people become motivated and empowered to do things badly, and yet keep going, that's where the magic happens. These teams continued to compete in parallel, and they came back in 2015, 18 months later. While not every humanoid robot succeeded, this one knocked its own head off. Notice that the tethers and cords are gone. Multiple robots fulfilled the goals. In this picture, picking up and using a hand drill. I was there as 10,000 people cheered as the KAIST team robot slowly completed the tasks by walking upstairs. Now, it took 44 minutes to do what we could do in 10 minutes, and KAIST made the fastest robot. After KAIST won, I got to meet the director of the competition, and I asked him if he was going to do another robotics competition. He said, no, I'm not, because they are done. He forecast that once robots could solve a problem in 44 minutes, the exponentials combined with multiple teams could take over. 44 becomes 22 minutes, then 11 minutes, then 5 minutes, faster than what we can do. But here's another example of an exponential technology. Last year here in California, I was excited to get this earthquake alert on my phone, telling me about an earthquake 360 kilometers away. While this one earthquake didn't affect me, I know that future ones could. A few seconds of warning can make a difference, and it's good that this exists. However, this was 2020. Other countries have had this type of warning system for many years. Mexico City has had warnings for decades. How can it be that in California, a technology which is desirable and demonstrated can still take so many years to arrive? I will argue that technology is not enough. We have to look beyond exponentials and look beyond the experts working in an industry when we as stakeholders want change. For example, when you look at COVID vaccine development, the vaccines did not involve new technologies for the most part, but what they did involve is new approaches to using these technologies. Multiple teams worked in parallel. Multiple teams had funding to be able to go and start manufacturing even before they had the regulatory approval for these vaccines. So these vaccines launched in a much shorter time than had happened in the past, not because of a change in technologies, but because of a change in the process of how we use technologies. Similarly, we have an amazing amount of information regarding COVID and virus and medical responses. We can see that there are nearly 400,000 articles available, and available more quickly and without cost to people around the world. This includes, in some cases, the data and models for other people to examine and try themselves. Researchers have found ways to get results out quickly so that feedback can happen quickly. The technologies didn't change, but the motivations changed. And while this amount of information is overwhelming for any one person, we have teams of people assisting as volunteers, and we also have early digital analysts, the AIs which can help us spot patterns. And the type of connections grew. When protective equipment was low in supply in the United States and around the world, the maker community and others stepped up to help. They used old technologies and existing technologies to create new partnerships. By being more public about problems and shortages, the medical community found expanded help for what they needed. I believe this is a critical lesson that we must learn from this. The speed and the scale of COVID-19 responses in 2020 and 2021 are not from new technologies, but new approaches, including working in parallel, expanded funding, and making individual decisions, such as when journals asked peer review to take 60 or 80 days, or when people published preprints. It was not impossible to do these before, but we chose to do them now. This is a lesson for any individual goal within the Sustainable Development Goals. We now have a little over 9 years to get them done on time, and we don't want to be late. If we accomplish a goal in 2035 instead of 2030, then many people will be harmed and negatively affected because the solution was possible, but it arrived too late for them. These people, they will instead want to ask us, if a goal is not impossible, what can we do to finish it in 2027 instead of 2030? The experts working on these problems, of course, know the deep and complex difficulties of these problems. They also will see that the first time we as a planet tried to accomplish these types of goals with the Millennium Development Goals of the prior 15 years, we only got so far. We made improvements in each area, but we didn't accomplish all of each area of the Millennium Development Goals. If we couldn't succeed in those prior 15 years, from 2020 through 2015, what could make us succeed now in the current set of goals? We must look at examples. For example, more than 18 years ago in 2003, the DARPA agency in the United States launched their autonomous car competition. Because of exponential technologies, the necessary computation could be inside of a car, even if it completely filled the back of a car, as you see here with the Stanford autonomous car. As with the robotics competition, in the first event, everybody failed. No car could do everything that was required. No car went more than 12 kilometers. However, each of many necessary capabilities was demonstrated by at least one car. So now, in the background, everybody is realizing that this is now not impossible if you can put these capabilities together. So, multiple teams worked in parallel, and 18 months later, multiple cars completed the race. Later, one company, Google, was able to take several of these teams and put them together with sufficient funding. And less than a decade after the competition, Google had their own working prototype of autonomous car. And it keeps going. Here is a picture from Waymo's San Francisco fleet this year, where they are regularly testing autonomous cars. And of course, multiple places around the world have autonomous cars out there running. And this is in part because all of the work was accelerated because of the competition. This is a competition where everybody failed at first, but those teams picked themselves up and kept going, and new teams were inspired to join in. And of course, we keep on seeing the evolution of these technologies. We see prototypes or working versions of these which are much larger or much smaller, with different capabilities. This is an example of how change can happen. Now, change is made in part by very smart people, by experts. In May of 2020, I was listening to an interview with Dr. Danu Kahneman, the psychologist with a prize in economics in memory of Nobel. We call him a Nobel Prize winner. During the question and answer time, I got to ask him, what surprised him the most about COVID-19 so far, just a few months in? He had an intriguing answer. He said, what surprised him the most is he surprised himself. What did he do? He told a story about how he himself was traveling earlier, and while traveling, he read an article that said that the country he was in had 100 COVID cases. At the time, he accepted this number without worry. He read it, and he had no reaction. And this surprised him later. Why? In retrospect, he should have been more scared because the pandemic was displaying an exponential nature. And in an exponential nature, if you have 100 cases, then very quickly you have 200, and then 2,000. Experts must constantly spend time going back over their attitudes about change. For example, we today are used to electric cars. If I tell you that more than 20 countries are phasing out the sale of gasoline and diesel cars, today you will not be surprised. But think back not long ago to the year 2014. 2 years before that, Tesla had sold only 2,500 cars. Even in 2014, they sold 35,000 cars. Hyundai, in contrast, that year sold 4.9 million vehicles. In that year, I met with executives from 2 large car companies. When I mentioned Tesla, they were skeptical, in part because they hadn't driven one. The executives were especially skeptical about the idea that Tesla's cars would keep getting better while also dropping in price. And there was one additional change that Tesla made clear in their model. With Tesla, customers can request software changes to the product, and later on, sometimes just weeks later, Tesla can add these in an upload. With other car companies, you get new features by buying a new car. Once customers get used to this ability, this new ability of a car company, the unresponsive, old-fashioned style of car companies feels outdated. Now, this is all to say, if experts like Dr. Kahneman can be surprised, we ourselves should not think that anyone is immune to being surprised. Also, there is another problem, in that experts might feel, and they can feel, that because they understand the problem in detail, they will feel that only they can come up with solutions. I'm sure you have met people like that. Perhaps you have been that expert. However, this is a hypothesis, a testable hypothesis. It is reasonable for the rest of us to ask any expert, have you tested this hypothesis, and how have you tested it? Because here, for example, over a decade ago, there was a data science competition in how to map the dark matter of the universe. The winner was a glaciologist. If you had asked ahead of time who the winner is going to be, experts in this area might say, well, it's going to be one of us. It's going to be a physicist. It's going to be an astronomer. Glaciologist was not on the list. Of course, you might say, this is a narrow problem, but what about complex problems? During the Ebola outbreaks, governments around the world realized that the speed of change wasn't enough. Once again, they created incentives. They created competitions for multiple teams around the world to come together to work on all the slowdowns in the system. One area that needed improvement was protective suits. They were hot, heavy, and very difficult to put on or take off. I will tell you now that the teams in these competitions made breakthroughs. One team's breakthrough is an ongoing project. Now, guess who made the important insight on that team? If you asked experts ahead of time, who do you need to have this type of insight, they might list doctors and other healthcare workers. They might mention manufacturers, right? Ahead of time, they are not going to say wedding dress designer with experience in theater costumes. Now, as soon as I say it, it makes sense. Theater requires quick changes, and a designer of wedding dresses understands the body and body movement. But what is obvious in retrospect is not obvious ahead of time. Again, here you have parallel work, and you are open to unexpected teams and unexpected people. If you have problems that are not solved yet, you might not be the best judge of who will help solve them. We are seeing signs of this in many places. Here in the 2020 Consumer Electronics Show, we see exhibitors that we expect. What is important to observe are the companies and organizations that not everybody would expect to see. Here, for example, we see that an equipment manufacturer now works with big data. If each piece of equipment can produce terabytes of data, how might organizations who work in food supply work with companies like this one to have better data, to have, for example, advanced warning about change? First, these organizations have to know that these companies have these capabilities. These organizations should not define ahead of time who they'll need to meet. They need to seek them out. And here also is AARP. This is an organization that advocates for older people in the United States. It is famous in the US for tracking down everybody over 55 and inviting them to join. They are running programs to accelerate the development of tools and capabilities that help people over 55, but also help people at all ages. If they are doing this, we, who are stakeholders in other organizations, whether they are NGOs or our governments, we must check that they are using good methods to increase innovation. By the way, these competitions keep going. Here is a competition to improve personal flying devices, including improvements in noise and in energy efficiency. No one won, but 3,800 teams joined in at the start. Like the humanoid robots, we want these to exist. Drones can deliver machines to help with a heart attack, but what might be the fastest way to bring a doctor? Going back to Moore's law, what today is called a law started off as a desperate marketing decision by a bunch of inexperienced entrepreneurs who were dropping the prices of the product to get sales. When I, as a technologist, am talking to scientists, I am careful to tell them, we in technology, we know that Moore's law isn't a law. However, if we called it Moore's small observation and we don't know what's going to happen next, it wouldn't have become what it is. It is a self-fulfilling prophecy. Moore's law became a goal. It became a decision that industries together could reach and have reached. Today here, we can see scientists adopting this very tool and this mindset for the Carbon Law Project. Here, industries and companies pledge to reduce their carbon by half every decade until 2050. These scientists are borrowing a tool from technology. Even though it is a marketing tool, it is the right tool for them to use. This is all to say that if we rely on traditional approaches, we will get traditional results. If we want new results, we must encourage new approaches, and these new approaches will come from the outside. I think it is a good rule in technology to realize that the purpose of version 1 of anything is to inspire people to do it better. This is true of any one technology. It is also true of competitions and ways that we create innovation. The makers of competitions improve and expand. Competitions improve, ways we do innovation improve, and we have better access to them. So again, if an expert or a group of experts think that they've got the best solution to a problem that they understand well, this is testable. Have they tested it? How have they tested it? All stakeholders in a problem have the ability and the responsibility to know that experts regularly test themselves. When it comes to innovation, I believe many experts think that they are working as fast as they can. It is understandable. Who would want to think of themselves, there are tools and methods that could be useful, but I'm choosing to ignore them? This is true of large organizations, and we must take this into account with our attitudes for startups and where innovation might come from. So I spoke to energy researchers at a large United States lab about innovation. I could have started off giving them 5 examples or 50 examples of energy startups, but I didn't. Why not? Because in that room, there's going to be somebody who's an incredible expert, somebody that everybody else is going to look at to see what they think. And that person might say, no to every one of those 50 startups. They will question every one of them because, in reality, most of those startups will fail because most startups do fail. Instead, first, I told them about startups in space. Space used to be the domain of large governments and large corporations, but now space has a thriving startup culture. If this happens in space, why wouldn't it be happening in energy? Now, there also exists entrepreneurship, internal innovation. Representatives from a global energy company a few years ago were briefing me and others about their innovation strategy. They, as a company with more than 100,000 employees, they were facing substantial challenges and problems. We all have been seeing how energy itself and as an industry has been changing because of exponential technologies, and not just the technologies, but choices about exponential technologies. For example, solar has been steadily improving, but we also know that the deployment accelerated because of the technology, but also because of governments supporting and subsidizing production and installation. You should go back and look at forecasts of solar growth that were made 10 years ago and 5 years ago, and compare those forecasts to the reality of today. So this energy company wanted to improve innovation. They were saying, yes, we want to do hackathons. We want to do internal competitions. I heard them and said, that's a great idea. However, one idea, I think that your first hackathon should be in healthcare. And they looked at me and they said, you do remember that we are an energy company, not a healthcare company. And I said, exactly. That's exactly right. You are an energy company. Imagine that you are doing a hackathon and that you have a room and a table, and the CEO is at that table, and that table is generating ideas. Imagine that you also have somebody who's been at that company for 1 month. Whose idea do you think is going to come out from that table? You might think, well, everybody has an equal opportunity, but no, it is very likely, extremely likely, that that idea is going to be the one from the CEO. We know it is safer for employees to allow the senior manager's ideas to rise to the top. If instead they first practice in an area like healthcare, everybody can learn to bring new ideas in a way which allows the new person's ideas and the founder's ideas to rise up equally. Now, I want to give you an analogy from science. Imagine I tell you that researchers are about to do an experiment. These researchers are motivated to make discoveries. They are motivated to change the boundaries of knowledge. Now, imagine also I tell you that before they run the experiment, they 100% know the results they're going to get. They are absolutely certain of the results. Is this an experiment? I will say no. It is not an experiment. It is a demonstration. A true experiment has an unknown and the possibility of failure. And we admit failure is painful. Demonstration is safe. Demonstrations are good for teaching or to check on what other people have done. But if you know the result ahead of time, you are not adding new knowledge to science. Now let me ask you, if you are about to ask a question where you know the result you're going to get ahead of time, are you really asking a question? I will say no, you're not. You are also doing a demonstration. You are not going to be pushing the boundaries of knowledge with this question. So, what are the reasons to do this demonstration? Well, again, you might be doing it to show off. You might be doing it to feel safe, but a better question and a better conversation happens where you do not know the answer ahead of time. And it feels painful to ask unsafe questions, these unknown questions. It's also very hard to listen to them. Teams must practice. This is all to say that if an organizational practice does not allow experiments, it is not going to receive the benefits of experiments. If organizational culture pushes people to asking safe questions, questions that don't push the boundaries of knowledge, you are not going to get the benefits of real questions, questions which can expand knowledge within the organization. And let me give you an analogy about expertise. You have heard the idea that if a person is lost in the woods, or lost in a snowstorm or dust storm, they will walk in a circle. We've all heard it, and scientists have tested this idea. It is true. Here, people who are experts at moving around start to walk in circles if they cannot see. If they have a GPS or a compass, or they can orient on a distant object, they will walk in a straight line. But the moment they say, I'm now an expert in walking in a straight line, I don't need these outside tools, they will go right back to walking in a circle. Expertise is similar. Think about the joy of expertise. Expertise is like magic. You look at a problem and you can quickly, almost instantly, start seeing solutions. However, if you are about to make a major decision, what tools are you going to use? Are you going to use the tools that you're used to and the people that you already know? Will you lean towards how what you know works? Yes, it's human nature. And every time you lean just slightly in one direction, you will start thinking in a circle. You will start thinking within your area of expertise. It is very hard to step outside of your own head. Just like GPS or a compass, you can have tools and people who are there to help you. But the moment you say, I'm an expert in thinking not like an expert, you're going to go in circles. An organization must expect that change requires extensive and continuing practice. This practice must include testing our assumptions about how well we accept the possibility of change. And we must include knowing the difficulties of adapting to change. Conversations in which newcomers are asking real questions require the experts in the room to practice answering them. And experts, in turn, must look to recent history to understand if they are ready to help speed up innovation, or are they ready to slow it down? If you are in broadband services and you first heard about the potential connectivity from Starlink, were you skeptical? If you were, this skepticism could make sense in 2018. However, now that Starlink has 1,600 satellites up, have you tested yourself to see if you've updated yourself and your assumptions? For 2022, it is important for organizations to take time to test that what they assume about normal business issues, whether it's supply chains or competition, they need to test if those are still the case. They also must test if they can help with specific sustainable development goals. We have to test ourselves on what we assume about exponential technologies, both the good and the bad. If robots have become a reality, will the fear of automation that we have had for decades also become a reality? As with the technology itself, we first meet these problems in fiction, but now we know it is not impossible. So what should we do? Because, yes, automation can make us fearful. If your job is looking at pictures to identify cancer cells or abnormalities, your job is going to go away because of automation, AIs which do picture analyses. However, if your job is treating and curing cancer, then automation saves you time. It means you don't have to spend time looking at pictures when instead you can do your real work with the patients themselves. Now, this upcoming possibility of automation changing jobs, I call it the possibility of economic climate change. And I'm using this analogy on purpose. Right now we are seeing 10,000 people shortly. They will show up for COP26 to discuss serious issues on climate. Who, similarly, should we have discussing economic climate change? This is the 21st century. It is now possible to ask everybody what they think about this topic, and ask everybody in a city, in a region, in a country, in a continent, what they want to be doing in 5 to 10 years. We have the technology to do these types of conversations, but technology is not enough. Are we choosing to use them to solve problems at this scale? Now, what we can conclude from the lessons of COVID, from the lessons of these other technologies, and from thinking about the nature of experts, is that innovation is a practice. Problem solving is an attitude for everybody, not just experts. What we are able to do in 2022 and in the future will depend in part on what we choose to do and who we ask to help. Think back to 107 years ago. Here's another Nobel Prize winner, Dr. Marie Curie. She was a researcher running a laboratory, but she also saw how a new technology, the X-ray, was not being used enough in the war. She saw that 3 technologies, the X-ray, the vehicle, and the generator, could be combined together to create mobile X-ray units. She learned to drive. She learned to drive to help deliver these tools and to ensure that they were being used. Her work to rapidly expand access to X-rays saved lives. Over 1 million people had X-rays during that war, in part because of her. That she could contribute and that these X-rays would save these lives might now seem obvious in retrospect. Not at the time. She combined her expertise with the ability to push through difficulties. Which means when we return to these, the Sustainable Development Goals, we have to think about where we want to be. If we are done with even one goal in 2030, it will be because of what we started in 2028. In 2028, we will have sets of scalable projects made by teams who today do not even exist, supported by funding in ICT tools which do exist today, which are possible today. I cannot define what these projects are, but I can say they exist in 2028 because of what many more teams altogether around the world started in, say, 2025. And these teams and these projects came out of 2022. And what starts in 2022 is up to us. To finish on time, we must start on time. The ICT industry is behind these capabilities and connections, all of these between stakeholders around the world. I would ask you that in 2022, the ICT industry continues to move forward and also tests if it can move faster to support the projects of 2022, leading to success by 2030. Thank you again for this opportunity to talk about exponential technologies, innovation, and adapting these in the near future. I look forward.
네, 여러분 박수 부탁드리겠습니다. 네, 이 CNN이 선정한 주의 깊게 봐야 할 7대 기술 거장 중 한 분입니다. 또 풍요의 미래라는 책의 이 공동 저자이시기도 하고요. 싱귤래리티 대학교 캐서린 미루눅 교수님의 2022 ICT 혁신에 대한 강연을 함께 하셨습니다. 너무나 좋은 발표였고요. 지금 저희가 이제 질의응답 시간을 위해서 바로 다시 한번 실시간으로 연결해서 인사를 드려볼 텐데요. 자, Professor 미루눅, hi.
Yes, good morning. How are you?
Thank you very much for joining us. That was very insightful presentation. So we have some questions from our online participant. So I will give you that questions. 자, 저희가 말씀드린 것처럼 지금 온라인을 통해서 많은 분들이 관심을 보여주고 계시고요. 질문이 꽤 많이 올라왔습니다. 주최 측과 제가 협의를 해서 저희가 2가지 정도의 질문을 꼽아봤습니다. 그래서 직접 질문을 드려보도록 하겠습니다. 먼저 첫 번째 질문을 여러분께 소개를 해드리면 혁신과 기하급수적인 기술, 이 2가지의 교차점에서 업무를 수행하려면 어떤 자질과 역량이 필요할까요? 라는 질문이 올라와 있는데요. 이 질문 드려보도록 하겠습니다. So here's the first question. What qualities and competencies are needed to work at the intersection of innovation and exponential technologies? Please answer that question.
Yes, thank you. That's a very important question. And let me start off by saying, of course, I am from Silicon Valley, and so my perspective is influenced heavily by this. So I think a very important quality that people must have is to have a tolerance or to have a desire to do experiments and to have a very positive attitude towards experiments. And to have a positive attitude towards experiments, you must have, in turn, a tolerance and a positive attitude towards doing experiments that can fail, as I said. So attitudes towards failure are something that people must check within themselves and test within themselves. So experts, and by expert I don't just mean the very leaders, but people who've been working in a field for a while must regularly test how they are doing and how they are doing experiments. And when they test their assumptions, they must bring in people from the outside, and they must test them in an interdisciplinary manner. Now, as I say, many times experts assume that if they understand the problem, they are the only ones who can solve it. And if they are not testing this, they are just imagining this. They do not know this to be true. I think another very important idea for working with exponential technologies is understanding how versus why, to be able to separate goals from methods. If a goal is good and the method that you were using, the technology that you were using 5 years ago or 10 years ago was one way to get to that goal, today the old method may be obsolete and the people who were working on it previously might be insufficient. I also think it is important to study the history of Silicon Valley. For example, in 1994, the company General Magic launched the very first smartphone. Now, 1994 was very early, and this company failed in many ways. However, the people who worked at that company, including people who were just out of college and university, they went on to additional companies. They moved in and out of large companies such as Apple and Google. And their ability to move in and out was part of what made these companies successful later on. So again, we must check our attitudes towards flexibility. If people are not able to come in and leave a company to be able to have experiments within the company or doing their experiments elsewhere at startups, then that shows that the company is inflexible. And if you're not flexible, it is hard to do experiments.
Okay, thank you very much for your answer. So we need some time to translate. Okay, so 아마도 여러분들께서 아마 거의 포인트는 잡으셨을 것 같은데요. 제가 간단하게나마 좀 요약을 해서 설명을 해드리면, 일단 질문이 혁신과 기하급수적인 기술, 이런 외부 환경 속에서 어떤 자질과 역량이 필요합니까? 라는 질문이었습니다. 혁신과 기하급수적인 기술에 대한 긍정적인 태도를 언급하셨고, 실패를 용인하는 어떤 실험 환경을 만들어야 된다. 계속해서 자기 자신을 도전시킬 수 있는 환경을 만들어야 된다라는 언급을 해주셨습니다. 어떤 문제를 두고 무엇이 가능한지 불가능한지를 외부 인원과 내부 학제 인원들이 머리를 맞대서 정기적으로 조사하는 것이 필요하겠다라는 조언을 해주셨고요. 그 문제를 이해했다면 최적의 솔루션을 제시할 수 있을 것이라고 말씀을 해주셨습니다. 마지막으로 목표를 도달하는 방법에 있어서 그러니까 어떻게, how, why 이 차이를 알고 있는 것이 무엇보다 중요하다는 말씀을 해주셨고, 그래서 이 스마트폰 탄생 같은 경우에도 1994년 제너럴 매직이라는 회사 이 사례를 살펴주셨습니다. 교수님께서 아무래도 실리콘밸리 출신이기 때문에 이 관점이 아마 영향을 끼쳤을 것이라는 언급도 해주셨습니다. So I explain it and briefly. So moving on to the next question, which is the last question for your presentation. 저희가 두 가지 질문을 꼽아봤는데요. 이제 두 번째 질문 제가 소개를 해드리도록 하겠습니다. 마찬가지로 지금 온라인을 통해서 질문을 해주셨습니다. 아마도 아주 오버럴한 질문이 될 것 같아요. 한국의 ICT 산업과 기술을 어떻게 평가를 하시는지, 그리고 향후 발전을 위해서 필요한 국가 정책과 방향을 제시해 주실 수 있는지에 대한 질문을 해주셨습니다. Okay, so this is the next question. How do you evaluate Korea's ICT industry and technology? And please suggest some national policy and direction necessary for further development in the future. Professor?
Yes, thank you. So again, I am in Silicon Valley, so my answer is influenced by this. Of course, Korea has a very large and extraordinarily important ICT industry. When we look at this, though, of course, the pattern has been very large companies, conglomerates. And the nature of conglomerates is that they can be filled with experts and they can be conservative. And so I think it is important for the Korean government to continue to support the growth and existence of smaller companies and of startups. And as I say, startups are experiments. So in supporting this, the government and the people helping to support this must, of course, accept the possibility not just of one round of failures, but multiple failures, because you're doing multiple experiments. And this can be hard to see at first. And so the government itself, government officials, I would advise, should start practicing this themselves. And this type of change can be uncomfortable if they haven't done this. I also think we must look at regulatory methods. Many times regulators themselves can not have a full conversation about how versus why, goals versus methods. Now, in California, 30 years ago, the California government made this mistake. They regulated automobiles by saying you must have zero emission vehicles instead of saying our goal is to have reduced emissions. Because of this goal, which was not obtainable at the time, California pushed hybrid vehicles as an industry out to other countries and perhaps slowed down the development. In another example, the city of San Francisco, when it was making regulations about certain types of lighting, dictated a particular method. They dictated and said that certain places must use compact fluorescent bulbs. And because they dictated a method instead of a goal, when LED lights came out, people were not able to switch over because it was against the rules. Now, I'm giving this larger and smaller example to be able to say that these regulators were not expecting these results. They did not want to have this happen, but it happened. So again, if this can happen to other people, we must accept it can happen to us. And a last area I think for governments to do is to practice even more to get feedback from outsiders, to get feedback for an industry from people outside of the industry or people who have left the industry. In addition, as I was saying, we must ask what is possible today that wasn't possible 5 years ago or 10 years ago. And so, for example, if there is a problem coming up, governments can start by asking everybody to join in the conversation. Yes, everybody come here. And when we're thinking about what people want for the future, we can ask everybody, what would you like to have in 2030? What is blocking you from getting there? And how might we work together to remove these barriers? So governments themselves can, and the people within them, can practice these, do experiments, and bring in people that they do not expect to bring in.
Okay, thank you very much for that question. 답변을 해주셨습니다. 제가 요약을 하는데 조금 많이 요약을 해드려야 될 것 같습니다. 저희 아마 이 프로그램이 계속해서 온라인 다시 보기를 하실 수 있기 때문에 조금 부족한 설명 같은 경우는 다시 재생하기를 추천드리겠습니다. 질문에 대한 답변은요. 우리나라의 경우에는 대기업 중심의 기술 경제로 구성되어 있어서 상당히 보수적일 수 있다라는 말씀을 해주셨습니다. 따라서 중소기업과 스타트업에 의한 혁신을 위해서는 여러 번의 실패와 경험이 당연히 필요하겠다라는 말씀을 해주셨고 이것을 받아들이고 꼭 지지를 해줘야 된다라는 말씀을 주셨습니다. 그리고 정부는 목표가 무엇인지 스스로 자문을 하고 해당 업계뿐만 아니라 이 외부 업계의 그 피드백을 받아서 이게 다양한 그 파티의 의견을 수렴하는 것이 필요하다, 중요하다라는 말씀을 해주셨습니다. 마지막으로 2020년 이전에 불가능하다고 생각했던 것들이 무엇이 있었는지, 그런 기술이 무엇이 있었는지 다시 한번 고려를 해보고 이를 통해서 전보다 더욱더 유연하게 행동할 수 있을 것이라는 말씀을 해주셨습니다. 자, 여기에 대해서 저희가 답변을 들어봤습니다. 저희가 시간 관계상 이제 2개 정도의 질문을 받아봤고요. 여기서 질의응답 시간을 마무리를 해야 될 것 같습니다. So once again, thank you very much for that insightful presentation and your answer. So before I say goodbye to you, would you please say hello or anything to say to our audience in Korea, please?
It has been an honor to be able to speak with you, and I look forward to finding out what changes are going to be occurring in 2022, including the new types of startups, some of which I've met people from, and I look forward to seeing what South Korea will be doing over the next years.
Thank you very much. 네, 이렇게 해서 연사님을 보내드리도록 하겠습니다. 다시 한번 큰 박수 부탁드립니다. Thank you very much for your time. Look forward to seeing you in Korea face to face. 네, 오늘 첫 번째 발표를 장식해 주셨고요. 정말 인사이프한 그런 질문, 답변까지 함께 하셨습니다. 함께 해주신 여러분께 감사의 말씀, 그리고 또 발표자로 참여할 수 있어서 영광이라는 말씀도 해주셨고요. ICT 발전을 기원하겠다는 마지막 인사말까지 들어봤습니다. 자, 세션 1 함께하고 계십니다.